This is checkpoint 6.28. They want us to find a potential function for a vector field f, which is equal to e to the x times y cubed plus y, comma, 3e to the x y squared plus x. All right, to find a potential function, we're assuming that f itself is a gradient field, which means it is equal to the gradient of some function f, which is the potential function. And if that's the case, the gradient is going to be in two variables, the derivative of the function with respect to x, comma, the derivative of the function with respect to y. And so if we're looking for the potential function, we want to undo these derivatives and see if we can come to a function that would agree with both of those. And to do that, let's assume that our function f is going to be the antiderivative of the first part, fx, with respect to x. And so we're going to integrate e to the x y cubed plus y with respect to x. And holding the y constant, the first term is going to be e to the x y cubed plus, and this is constant times x, so that's going to be x times y. And we want to allow for the possibility that we had taken the derivative of the potential function with respect to x, and we had some extra function of y here, which is constant with respect to x. Similarly, we will find the antiderivative of the second function with respect to y, and that's the antiderivative of 3e to the x y squared plus x with respect to y, and that is equal to, with respect to y, e to the x is constant, so this will be y to the third divided by 3, so that 3 would cancel, and we just have e to the x y cubed, and then x is constant, so there's going to be an extra y that pops up. Again, allow for a constant with respect to y, which is possibly some function of x. Now, if I collect these f terms that I got, and I see that these two terms are in common, I know that that's going to be there. And the g of y and h of x don't look like there's anything there to add on. So then we can conclude that your potential function f of x, y should equal to e to the x, y cubed plus x times y, and we can tack in a constant here. Now, if we take the derivative with respect to x, just to check, take the derivative with respect to x, this is going to be e to the x, y cubed, and the derivative of this with respect to x is just going to be y, and the derivative of constant with respect to x is 0. So that's that first one. And then if we take the derivative of that function with respect to y, this will be 3y squared e to the x. And the second term with respect to y would just be x. And again, the derivative constant is 0. So this is now the second function. And we've verified that we do have the correct potential function. All right, I hope that helps.